Hi, my name is Nico Yankovic. I'm going to be explaining question 6 on exam number 2. An urban economist wishes to estimate the proportion of Americans who own their homes. What size sample should be obtained if he wishes the estimate to be within 0.02 with a 90% confidence interval? If A, he uses a 2010 estimate of 0.669 obtained from the U.S. Census Bureau, or B, he has not used any prior estimates. So we're going to go to my work right here. We're basically trying to find n under two different scenarios. So our formula to do that is n equals p hat, 1 minus p hat, times 1 minus p hat, times z times alpha over 2 over e, which is our margin of error, and then that's squared, as you can see. So we plug in everything, and this is all given to us in the problem, or everything aside from the z alpha over 2, but we have a shortcut to that on our z table. So we have 0.669, 1 minus 0.669 times 1.645 over 0.02. That 0.02 is given in the problem, and this 1.645 is on the z table, which I'll explain in a second. And then that's squared, and it works out to 18.21. Now to just show where the 1.645 came from, how we got that from the z alpha over 2. Right here, we have a shortcut on the z table, the confidence interval critical values. You can see the z alpha over 2 is right there. And it says right here, if we have a 90% confidence in our critical value, for that would be 1.645. So that's where we get that from, right there. So the sample, and this works out to 18.21. So we know the sample size should be about 18, but not 18 exactly. So sample size should be about 18. And that was us. You'll notice here, the p hat is what we use from, this was given to us in the problem, and now the thing that's going to change in part B is that this is based off a prior estimate, and we're no longer basing it off any prior estimates, so that's going to disappear. So we're simply just going to have, so our equation for B is basically, it's similar, but we have a set 0.25 times 1.645, which we got from our z table, over 0.02, which we got from the problem. It's our margin of error, as you'll see here. So it's basically this just times 0.25, and we're still squaring it. And that equals 20.56. So the sample size should be about 21, because 20.56 rounds to 21.